Sup? We are going to continue our discussion on trigonometric functions, and what's really going to help us out, I think, or at least I hope, is the use of triangles and pictures to help us visualize what's going on with some of these trig values. Right? So let me just remind you a little bit about right triangles. Right? If you remember, for our triangle, right, we've got three sides, right, and the angles sum to 180 degrees, right? And in a right triangle, one angle is 90 degrees, right? And of course, if it's at 90 degrees, that means it's perpendicular, so it goes straight up and down like this, and then we can connect our third side, and there's our triangle, right? So maybe this one's 5, this one's 12, and this side is 13. Right? Of course, if you have a right triangle, right, then you can use the Pythagorean theorem, right, which says if I have a right triangle where there's my right angle and I have these sides A, B, and C, to where that longest side is the hypotenuse, right, then the Pythagorean theorem says as long as you've got a right triangle, that A squared plus B squared is going to be C squared. Right? So if we come back over to this example we've got here, does 5 squared plus 12 squared actually equal 13 squared? Right? Well, this is 25 plus 144. 13 squared is 169. So yes, this is a right triangle. Okay? So we will next think about how these trig functions can be found in a right triangle like this. So let's say I have this angle theta, right? So if you look at theta, if you start here and go straight across from theta, right, that is the side that is opposite the angle, right? Of course, the longest side here, that's the hypotenuse, right? And the other side is the side that's a part of that angle, right? So that's the adjacent side. Okay? So let's go back to this right triangle again. Right? And here's my angle theta. Right? If you have a right triangle, again, let me put these back on here. Okay, so there's the opposite side, hypotenuse, and the adjacent side. Right? In a right triangle like this, sine of theta is defined to be the opposite side over the hypotenuse. Cosine of theta is defined to be the adjacent side over the hypotenuse. And tangent of theta is defined to be the opposite side over the adjacent side. Right? So if we go back to this right triangle we had on the previous page, right, the 5, 12, 13 right triangle, right, if this is my angle theta, then sine of theta is the opposite side, which is 12, over the the hypotenuse, which is 13. For cosine of theta, that's the adjacent side, which is 5, over the hypotenuse. And for tangent of theta, that is the opposite side over the adjacent side, which is just 5. Wow, worst 5 ever. Right? And depending on where you put the angle, you could get different values. For instance, let me put a beta right here. Right? And if I asked you what is sine of beta, right? Well, remember what you want to do is if you start here at beta, go to the opposite side. So in this case, that's a 5 over the hypotenuse, which is still 13. Right? If I asked you about cosine of that angle beta, right? Well, the adjacent side is now the 12. Right? So that'll be 12 over 13. Right? And then tangent of that angle beta, right? That's the opposite side, which is 5, over the adjacent side, which is 12. Okay? So depending on where the angle is located in your triangle, it could lead you to different values for sine, cosine, and for tangent. Right? One way you can remember this, and you've probably heard of this before, right? If I have a sine function, a cosine function, and a tangent function, Right? For sine, we had the opposite side over the hypotenuse. For cosine, we had the adjacent side over the hypotenuse. And for tangent, we had the opposite side over the adjacent side. Right? So that comes together into one of our favorite words here, SOHCAHTOA. Right? And if you can just remember the SOHCAHTOA part, you can remember your sine, your cosine, and your tangent. Right? So if I gave you this right triangle, how about a 6, 8, 10 triangle? First of all, is it a right triangle? Well, you can check the Pythagorean theorem. So is 8 squared plus 6 squared equal to 10 squared? Right? So I have 64 plus 36, does that equal 100? Well, yeah. So 100 equals 100. So it definitely is a right triangle. So let's pick one of these angles. How do I pick this angle? Right? Let me call that one theta. Okay. If I asked you to figure out what sine of theta is, right, again, remember what you do is you start here at theta, you go to the opposite side, which is 8, put that over the hypotenuse, which is 10. Right? If I asked you for cosine of theta, right, well, the adjacent side here is 6, and the hypotenuse is 10. Right? And then if I asked you for tangent of theta, that's just the adjacent side, the opposite side over the adjacent side. Right, so we get 8 over 6. All right, so a lot of this is probably review for you. You get a chance to play around with it to kind of to hammer it home for you. But we can do a little bit more with these as well. Look at this particular right triangle. All right, so there's my right triangle. Let's say I have a hypotenuse which is a length of 12, and what about an angle here of 54 degrees? What if I wanted to find one of these two missing sides? Right? For instance, let's say I wanted to find this side x right here. Okay. Well, again, we can use that SOHCAHTOA stuff to kind of help us out. Okay. Because if you notice, I have this angle right here, right? So theta here can be 54 degrees. This side, x, that is adjacent to my angle. This number 12 right here, remember that's your hypotenuse. So what I need is one of these trig functions which combines the adjacent with the hypotenuse. Okay? And which one does that over here? That one does. Right? Because again, cosine of theta is the adjacent side over the hypotenuse. Right? So in this case, cosine of theta, well, theta is 54 degrees. Right? That's going to equal the adjacent side, which is x, over the hypotenuse, which is 12. Okay? And then this is just an equation that we can solve. Right? For some of these, we will need a calculator because we don't know some of these strange values, like for instance, cosine of 54 degrees. So that's okay. So we'll be using a calculator on this portion of it. All right, and if you plug this into your calculator, if we go to 3 decimal places here, cosine of 54 degrees is 0.809, right? So that equals x over 12. Right? I could multiply both sides by 12 to get 9.71 is equal to x. Right? So if we go back to this triangle, right, I could rewrite it like this. Right? The hypotenuse is 12, this side x is 9.71, and this is 54 degrees. Right? So if I wanted to find this last side, let's call it y right there, I could either use the Pythagorean theorem and say that y squared plus 9.71 squared equals 12 squared, right? And try to solve it from there. So this would be y squared plus, let's see, this is 94.25 equals 12 squared, which is 144. Right? So I would have y squared, if we take this over, gives me 49.75, And then if I just take the square root of that, 49.75, take its square root, gives me 7.05. All right. So then I could make this side y and write it as 7.05. All right, so let's try another one of these things. All right, so let's say I have this angle here, theta. All right, let me call this one x. How about this one could be, how about 8? All right, just kind of making one of these up. And let's let theta be 40 degrees. Okay. All right, so if I want to figure out what x is going to be, right, if you look at theta, I am dealing with the opposite side and the hypotenuse. Right? So again, if you go back to your SOHCAHTOA, which deals with the opposite side and the hypotenuse, that's the sine function. Right? So this tells me that sine of theta equals the opposite side, which is 8, over the hypotenuse, which is x. Right? And now let's just take 40 degrees and plug it in here and see what we get. Right? So sine of 40 degrees equals 8 over x. If you find sine of 40 degrees, you should get 0.643. That equals 8 over x. Right? We could write this as 0.643 over 1, and then I can cross multiply to try to solve this to get 0.643 times x equals 8 times 1, which is 8. And then to solve this, let's take this 0.643 times x, and let's divide both sides by 0.643. Right? And that will give me x equals 12.4. Okay? So my triangle now looks like this. Right? This side is 8, that side is 12.4. There's my angle theta. Right? And then to find this last side over here, if we call it y, I could either use the Pythagorean theorem, or I could set up another trig formula. For instance, if you look at the triangle that we've got right here, tangent of theta is equal to the opposite over the adjacent. Right? So I could just set this up and, again, let theta be 40 degrees, plug it in there, and then solve it for y. So we have a couple of ways we can find that missing side if we need it. Okay? All right, so look at this right triangle. Right? What if I call this side 9, this side 12, and this side 15? Right? You can check, but you'll see that it does actually fit a right triangle. Right? If I gave you this angle theta right here, what are my 3 trig functions associated with theta? Right? In other words, what is sine of theta, what's cosine of theta, and what's tangent of theta? Okay? Well, again, if you look at sine of theta, that's the opposite side over the hypotenuse. Right? So the opposite side is 12, the hypotenuse is 15. Divide them both by 3 to get 4/5. For cosine of theta, that's the adjacent side over the hypotenuse. The adjacent side is 9, the hypotenuse is 15, and you can divide those both by 3 to get 3/5. For tangent of theta, that's the opposite side over the adjacent side. So that gives me a 12 over 9, which is 4/3. All right. What if I picked this angle, beta? Okay. Could we find sine of beta, cosine of beta, and tangent of beta? Well, for beta, the opposite side is 9 and the adjacent side is 12. So for beta, if I use the opposite over the hypotenuse, that'll be 9 over 15, right, which gives me 3/5. Right? For cosine of beta, that's the adjacent side over 15, so that gives me 4/5. And for tangent, that gives me the opposite side, which is 9, over the adjacent side, which is 12, which gives me 3/4. Okay, so we can use these trig ratios to figure out all of these values for sine, for cosine, and for tangent. Okay. All right, so the last thing I want you all to know is this. All right, this is our unit circle from the last time. The values I want you to know for sine and cosine and tangent are, again, the main axes values and these three values in the first quadrant. Okay, so in other words, if I said to you, what is sine of 45 degrees? I want you to know off the top of your head that's going to be square root of 2 over 2. All right? Or if I said, what's cosine of 30 degrees? All right? I want you to know that that's going to be the square root of 3 over 2. All right? Or if I said to you, what is tangent of, how about pi over 3? All right? Well, tangent of pi over 3 is square root of 3. All right? All right. Now, how do you know these things, or where do these things actually come from? Let's look at this first one real quick, and I'll show you where it comes from, and hopefully you'll just believe that all these other trig values actually just come from right triangles. Okay. All right. So if I wanted to ask you for sine of 45 degrees, all right, think about what we need here. I need a right triangle, right, and let's say this is 45 degrees. Right. Now, if you remember, for the triangle, these angles have to add up to 180 degrees, right? Which means this right triangle right there, that's already 90 degrees. Right? This angle gives me 45 degrees. So in order to add up to 180 degrees, this angle right here also has to be 45 degrees. Right? So what we have here is, whoops, I can't spell, is an isosceles triangle. Right? And you know it's an isosceles triangle for one of two reasons. First of all, if these two angles match up, the two smaller angles match up and they're both the same thing, then it's an isosceles triangle. Right? Also, that means that this side and this side have the exact same length. Okay? So for sine of 45 degrees, I'm using this isosceles right triangle, or right isosceles triangle, to figure out what this is going to equal. Okay? So let me redraw it over here. All right, so there's 45 degrees, and I'm trying to figure out what sine of 45 degrees is going to be. Okay. Well, if it's an isosceles right triangle, then I know that this side and this side have the exact same length. Okay, so let's give those length, how about x and x? Okay, and for my hypotenuse that's over here, it could be something completely different, and it will be, so let's call that y. Okay, and if you remember with your Pythagorean theorem here, I know that x squared plus x squared is supposed to equal y squared. Okay. All right, so for sine of 45 degrees, all these right triangles are going to have the exact same ratio, so let's put some numbers on this thing. Right? So if this side x is 1, that means this side x is going to be 1. So what about the hypotenuse over here? All right, again, let me call that thing y. I know that 1 squared plus 1 squared equals y squared. So 1 plus 1 is y squared. 2 equals y squared, which means y is the square root of 2. Right? Again, I don't need to worry about the plus or minus here because we can't use a negative distance. Right? So if we look at this angle 45 degrees, what is sine of 45 degrees in this triangle? Right? Well, the opposite side is 1. The hypotenuse is the square root of 2. So it's 1 over the square root of 2. All right, but again, kind of an embarrassing mathematical faux pas is having a square root in your denominator. So to get rid of that, let's multiply the bottom by a square root of 2, and of course to balance it off, do the same thing up at the top. Okay, so this says that sine of 45 degrees is the square root of 2 over 2. All right, so that's one of those values that I'm going to want you to know off the top of your head. Okay. And we could do the same thing. We can make these right triangles and figure out what sine of 30 degrees is, what sine of 60 degrees is. Same thing for cosine. I just wanted to show you where one of these comes from. Right? So it's going to come from just these right triangles. So when that number pops out on your calculator, it's not magic. It's not something that's made up. It just comes from basic geometry. All right, so let's look at some of these other values that I really want you to know. All right, so here's my unit circle. Right? And also remember, you're given these radian measures right here. So remember, this one is also 30 degrees. There's 45 degrees, 60 degrees. This one's 90 degrees. There's 0 degrees, and so on. Right? So with this unit circle, you can read off these ordered pairs. So if you go back to the 45 degree example we've been talking about before, if you look at this ordered pair, square root of 2 over 2, square root of 2 over 2, right? They kind of give you a hint here on how you can read these things. Right? This first one is my cosine value. So that's cosine of 45 degrees. The second one is your sine value. So that's sine of 45 degrees. So we can read these off my unit circle like this. Right? If I asked you for, how about cosine of 30 degrees, what you could do is you could go over here to 30 degrees, right, and take the first one because that represents cosine. So that's square root of 3 over 2. Right? If I asked you for sine of, how about 120 degrees? Right? Well, if you convert it into radians, right, 120 degrees times pi over 180 degrees, right? 120 goes into 180, 2 pi over 3 times, right? Divide them both by 60, right? So that's this one right here, right? And sine is the second value, so that's a positive square root of 3 over 2 again, okay? So let's go back to this unit circle. All right, so if you remember, the ones that I want you to know are all of these right here in the first quadrant, right? And then the values that are also on the axes right here, right? So basically know all the ones for 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90, 180, and 270, right? And in terms of radians, that's 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2. All right. So here's a little chart I would make if I were you all. All right. Have maybe a degree measure over here, right, of 0, 30 degrees, 45 degrees, 60 degrees, 90, 180, and 270. Right? And then have a radian measure of 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2. Right? And then think about what all of these cosine values are going to be. All right, so if you remember, the cosine values are the first part of the ordered pairs. So for 0 degrees, we use the 1. Right? For 30 degrees, we use the square root of 3 over 2. And then we use square root of 2 over 2, square root of 1 over 2, and then 0. And then we have a negative 1 and a 0 for that one. Okay? For sine, it's the second part of the ordered pairs. So that one would be 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, 0, and negative 1. Okay? Of course, once we have sine and cosine, we can figure out tangent pretty easily. If I wanted tangent of 60 degrees, nice writing, that's the same thing as sine of 60 degrees over cosine of 60 degrees. Sine of 60 degrees, if you just look at this column right there, is square root of 3 over 2. Cosine of 60 degrees is 1/2. Multiply the top and bottom by 2 gives me square root of 3 over 1, which is the same thing as the square root of 3. Okay. So what I want you all to do is, again, to know the trig values in this first quadrant and on those main axes, and that's pretty much this entire chart that we've got right here. Right. So I want to be able to ask you, hey, what's cosine of 60 degrees? You can say 1/2. Right. What is sine of pi over 4? That's square root of 2 over 2. Right. What's cosine of pi? -1. Right. What's sine of 270 degrees? -1. Right. So the sooner you sit down and learn these things, the better. Maybe you just make little flashcards, right, to where on one side of the flashcard it can say cosine of pi, and on the back side of the flashcard it could just say -1, right? Or maybe on another flashcard you could have, how about sine of 60 degrees, and on the flip side it would just be square root of 3 over 2. Right? So just write these things down as you're watching TV or doing something. Just flip through them during the commercials, and hopefully you can get to them pretty quick and easy. Okay. All right. So that's what we're doing for now. So we will go over more of this stuff tomorrow in class. If you need anything, come on by and see me. Right? And if not, I will catch up with you later. See ya.